Mr. Vakil graduated in mechanical engineering from the University of Madras in 1990. Starting his merchant Navy career in 1991 as a fifth engineer, swiftly rose to the rank of chief engineer, sailing with various Indian and foreign shipping companies. Vakil started a maritime training institution named Hindustan Institute of Maritime Training in 1998, and which is currently India's largest institute in terms of number of courses approved by the Directorate General of Shipping. He is the first marine engineer in the world to be conferred with fellowship by the prestigious Nautical Institute in the UK. He is currently the chairperson of the Institute of Marine Engineers in India and an active member of various professional bodies. He is an active member of various committees of DGS in framing and revising guidelines for various courses. He is currently pursuing his PhD at Indian Maritime University on the topic of maritime education and training for autonomous ships of the future. The title of his talk is The Application of Augmented Reality and Virtual Reality Technology for Remote Maintenance of Autonomous Ships. So please welcome Sanjeev Vakil. And the floor is yours.
Thank you. Thank you very much for this kind introduction, sir. Good day to one and all. Hope all of you and your family are keeping good health and are staying safe in these challenging times. I would like to thank International Association of Maritime Universities for accepting my paper and also giving me an opportunity to present this paper at this international forum. Special thanks to Captain Amir Monir Ibrahim and his team for his constant guidance. The topic of my presentation is application of augmented reality and virtual reality technology for the remote maintenance of autonomous ships. We all know today the new buzzword in shipping is autonomous ships. And there are lots of research being taken up by various stakeholders, including IMO, on this particular topic. Many feel that autonomous ships might take a long time. Few don't want to accept that, okay, this technology would ever come. And few feel that the jobs will last. There's a lot of debate going across, lots of risks and opportunities are being discussed across. But however, I would like to say that jobs are never lost. Technology only shifts the jobs. It doesn't lose, when seafarers would not lose jobs, but they might, I think, shift the base. So I think we all know that in 1980s, 2 decades back, so when the computers came, people thought that, okay, jobs will be going across. But then I think today, because of computers, we all have been working across. And in this pandemic, we know what we are doing across. So without this one tool, we would not have been, we have been locked at home and will not be able to communicate, but thanks to the technology. Today, I'm sure that, okay, even from home, if I'm going to start today morning, I think a person would probably forget to take his pen, but nobody will forget to take a mobile phone. And that's how in 2 decades, we have seen the drastic change in technology. So let's move to this autonomous ships, what we are talking of. Autonomous ships are going to be the ships for the future. The operation and maintenance of autonomous ships will vastly be different. It will require proper knowledge and understanding of many interrelated human and machine components. Today's skills for sure will become obsolete, and for running autonomous ships, and remote operated ships, new skills will be required to be done. The entire training will be revamped, and various skills, including augmented reality, virtual reality, HoloLens, and there are new other technologies which are coming across will have to be incorporated in the curriculum of the maritime education training, whether it's the pre-sea training or the post-sea training. Existing seafarers, there will be a bridge which will need to certainly fill up across. So let's discuss the whole changing work culture on board. The changing work culture on board, basically technology has been advancing at a tremendous pace. And to keep in step with this way of operating and maintaining the ships, also it's changing rapidly. In the past era of ships, we all know that with sails, the number of sailors required on working on board to rig the sails and operate the maintenance ships were large. the dawn of the Industrial Revolution and then consequent induction of steam engines on board for propelling the ships resulted not only in the reduction of crew on board, but also in the changes in the method of training, certification, and watchkeeping for the mariners. The introduction of diesel engines thereafter and the auxiliary machinery replaced the steam engines for propulsion of the ships and brought in further changes in the form of reduction of number of mariners on board. Now, with the rapid development of electronics and automation, their successful deployment in various shore-based industries promoted the introduction of instrumentation and automation on board ships as well. This move further brought down the crew requirement on board ships furthermore. Today, we are on a threshold of another major change in the shipping industry in the form of autonomous ships, which could drastically alter the size of the crew on board, possibly reducing it to either zero, or in case of fully autonomous ships, where small numbers of crew also might be done in remote control ships. So the reduction of crew on board ships over a period of time due to the introduction of newer technology has happened. If you see the right, up to the late 1970 and early 80, the crew complement on board average size ships ranged about 40 to 60 members. But due to the progressive reduction in the ship's crew ranging from 28 members, it went down to 10 members. And as a result, increasing automation on board, coupled with reduction in port stay, a number of days, from few days to few hours. And now I think few hours, it's going to go further down. So if you see a chart, I would just project that the next slide. This has been a real research which has been done from some shipping companies, thanks to those shipping companies who have shared the data. So from 60 to 70, where you had probably, I've made a comparison, Indian flag as well as the foreign flag, the number of crew who are existing on board from 60, 70, 1960, 1970, where it was around 45, 50, to today it's ranging of 18, 20 on board ships as on today. And that will further reduce. So all these developments over a period of time have contributed to the present day change of work culture on the board. And it is evident that these historic changes, that maritime operations would further be simplified by integrating the VR, AR technologies for maintenance. So autonomous ships, basically the past 3 years, we have seen a flurry of activities on the autonomous ships front in the shipping industry. The era of autonomous ships dawned on 3rd December 2018 with the world's first autonomous car ferry Falco, which made a maiden voyage from Pyrenean to Navo in Finland. The return voyage of this ship was remote control from a control center located about 30 kilometers away in Turku. The Irish leader, 70,826 deadweight autonomous ship. It was a car carrier maiden voyage from Mitsui. This particular vessel on 14th September 2019, it sailed out from Xinjiang in China to Nagao in Japan, and later on again from Nagao to Yokohama on 19th September 2019. Can you note that this vessel had the crew full complement on board for carrying out the other normal tasks, but it was just a test run, and that's how this vessel had moved. And recently this year, the world's first transatlantic voyage by a fully autonomous research vessel, Mayflower 400, fitted with ships carrying out scientific survey. This sailed out early in June 21. And if you see the reports on the website, I've come across the reports that I think after a few days of the vessel having started, I think it had some technical snags which were there, and because of which it had to return back. And now again, on 7th September, the vessel is again taken across. It's under test. So all these above mentioned events seem to prove that the world that autonomous ships are the reality, and that this type of vessels are the ships for the future. There is, however, an urgent need for a regulatory framework to be put in place for governing the safe operation of autonomous ships at the high seas. There are organizations, including IMO, then Maritime Autonomous System Regulatory Work Group at UK, Safety Regulation for European Unmanned Maritime Systems, SARMAS, and Advanced Autonomous Waterborne Application at Finland. All these organizations are doing in research on the guidelines to be created. Of course, the manufacturers, the training institutes, We all are, I think, working on it. The successful completion of these voyages of autonomous ships, what you saw in the top, was nothing but it only shows that autonomous ships is coming in. The technologies is something, what technologies are going to come in. There are lots, but then I'll concentrate on the augmented reality, virtual reality, and the HoloLens technology, which is part of my paper. So going across to virtual reality is it's a simulation of the real world around us. It's not physical, but a clone of the reality that can be seen, felt, and heard, thus giving one an impression that in actually it exists. In other words, it's a digitally created environment that makes one believe that he or she is physically present in this environment. A person can interact within the artificially created environment using certain special electronic devices. Virtual reality has already manifested itself in the shipping industry more than a decade ago in the form of a bridge simulator, engine simulator, liquid cargo handling simulator, and they're used for the purpose of trading for years together. And augmented reality, on the other hand, is a blend of real life and virtual reality. Augmented reality lets the user to interact with the virtual entities in the real world through the use of certain devices like optical head-mounted devices, in short, which is called as OHMD, which enables the AR and VR live audio and visual functionalities. Both augmented reality and virtual reality have same goal of making the user delve deep into the virtual world. With AR, users continue to be in contact with the real world while interacting with the virtual objects around them. Whereas the VR, the use is far away from the real world while being completely immersed into the virtual world. So augmented reality, though apparently lagging behind virtual reality, it has a lot of potential. Both this augmented reality and virtual reality allows experiences that are evolving more rapidly to be anticipated and are finding scope for applications in various fields. It's in the field of entertainment, education, science, medicine. Medicine, I think it's gone quite ahead, but in other places as well, it is coming into, and shipping per se, yes, it is something which is coming across. And the tools like HoloLens, it's a short name of holographic lens, and it's example for OHMD. If you could see the screen, I think it has a lot of things. It is a certain type of Microsoft reality. It has multiple electronic sensors, a visor, headband to wear across. A different type of HoloLens are coming to market right now. And this is one of them which I'm trying to show across. You could see in this HoloLens, consider that a case where 3 remote control autonomous ships are sailing at reduced shipboard staff in different geographical areas, say one in India, one in US, one in Egypt, and all of them requiring a show-based expertise for troubleshooting on board. It is quite obvious that a show-based expert cannot be present in different locations at the same time. But AR combined with HoloLens can enable this, and the show-based expert can interact with the ship staff on board all the 3 ships on a real-time basis and view the problem along with the guide and resolving them. That's what you see one of the engineers on the screen who is trying to have a turbocharger. He's trying to guide across as to do. I'll go further with a short video. I'll try to show across as to how the things are. Seeing is believing.
ARCS, we develop, produce, and service power management and automation control systems for the global marine market. We have a vision to digitally transform the maritime industry and are convinced that Microsoft HoloLens and mixed reality experiences will be instrumental in enabling us to make that change. We offer training to our customers at our dedicated training center in Japan, but because of its remote location, it's difficult for our customers to reach. However, utilizing the power of HoloLens, that obstacle can be removed, as users can receive training from anywhere in the world. Using 3D models, our trainer can explain the step-by-step process of how our equipment can be maintained. Trainees can see exactly what the trainer sees, in context and in human scale. And if one of the remote participants has a question about the equipment, the conversation can be translated in real time using the Microsoft Translator Support Service. Safety aboard vessels is very important to us at JRCS. we will decrease the risk of injury and human error by providing intuitive and efficient maintenance support through the use of mixed reality. If an engineer gets an alert that maintenance is required, the HoloLens can scan the unit and any necessary repair information can be viewed digitally. The engineer can then review the task list before performing the repair. This process empowers the engineer to make proactive maintenance decisions and in the future from any location, offshore or on. ARCS.
Yeah, so seeing is believing. Probably that short video, thanks to JRCS for having this video. And it was quite clear as to how the technology of AR, VR and the HoloLens mixed together, how does it do? So from this video, it has been seen that the main engineer is maintaining the operational status of all the systems in engine room so as to diagnose and rectify the problem. Through training and experience, this engine crew can read and interpret the various parameters displayed by the engine room instrumentation and employ their field for the normal operation in situ in order to examine the possibilities of maintenance of crewless autonomous vessels from remote locations. Developments have also been taken place for the creation of virtual reality simulated engine room based on a real vessel. Even though the end product is effectively a virtual simulation, the original audio from the engine room is recorded and used in providing more accurate and immersive experience to the users. Research is already on the applications of a remote server to feed audio and other data in the simulated virtual room and create a hypothetical scenario of failures for the purpose of testing and training. The results of this particular upcoming thing, I will just show a small further video where probably you would be able to see as to how. Just
play audio.
Vessel tagged with situation handling for all operators.
Right, bring vessel biz to collaboration table 1.
The OX Collaboration Table is a tool dedicated to teamwork and in-depth situation analyses and reviews, allowing ad hoc problem solving on a shared and flexible presentation platform.
We are looking at a vessel with possible propulsion motor failure. We need to decide whether she can sail to port with both motors or if she needs to shut down the other shaft line. Judging by the motor sound, I'm suspecting a failed feedback sensor. We could bypass it by changing to model-based open-loop feedback. And I'm positive she can then sail to port with both shaft lines operational. But I wanted to hear your opinions.
So there was one more way where which you saw that how the AR was used and what I was mentioning on the sound being recorded. And then again at institution also when the training goes across, I'll just come to that, how it can be developed. In fact, you could have a control station at the engine room at the institute itself and try to have such trainings being developed. So in short, I would say that is one way for maintenance. Today, even for the ship surveys, remote control ship surveys, you find,
ARC.
The inspection and surveys during COVID, yes, almost all the classroom societies have used a remote survey technique. And this survey has allowed the surveyors not to go on board and inspect tanks, inspect the engine room, inspect everything which they wanted to as per the regulations. So in the shipping industry, a trend of developing to enable classroom society surveyors to carry out remote inspections of ships' tanks using the purpose of custom-built drones. Drones have come in, fitted with suitable sensors like visual light range camera, infrared thermal camera, stereoscope with 3D camera, LiDAR. On similar lines, augmented reality and OHMD devices with HoloLens can be used for live presentation of engine rooms as well as decommissionary, and the equipment for inspection of certification for the surveyors from remote locations. As regards now maritime education training, it's well-known fact that evolution of maritime education and training closely followed the shadow. Like a shadow, the induction of technology, the training also changes. For example, as I mentioned in the past, that after the industrial revolution, when the steam engines were introduced to replace the sails, the propulsion of the ships went to the engine room. The concerned maritime authorities at that given time also changed the concept of training certification, that is STCW itself made a change. Those seafarers who were trained for steamships had to then later on get into appropriate training for MOT on the engine side. Subsequently, when diesel engines were replaced, even few people had steam and motor combined. So even today there are steam and motor ships. I think people do have the certificate of competency of steam and motor. In the nautical side, again, in the nautical side, the same scenario has happened in late 80s. The use of sextant together with ability to read and interpret the outputs presented like Deca, Omega. All those systems were considered as a treasured skill for positioning the fixing on board. But today, you see the GPS, GLONASS, ECDIS. ECDIS is a reality where I think STCW 2010 made it mandatory. And today, without ECDIS, I think nothing would move. ECDIS has come to a stage. It has been observed that the whole bridge is, I think, dependent on ECDIS. So the old things are still existing in the syllabus, but the syllabus would certainly be getting revamped shortly. And the new technologies will take up. So the whole STCW itself for the future, as it's changing across, it would have lots of skills which will be required. The AR, the VR, the blockchain technology. You will have machine learning. Various technologies will be required to do. Recently, I just saw a WhatsApp message 3 days back where I had seen that drones were being used for checking up the vessel smoke, how much of NOx and SOx is there. I think this was probably something some administrators started using this as well. So certainly the STCW, the future STCW has always changed 15 years from 78 to 95, from 95 to 2010. And the next STCW, which probably this decade we'll be seeing a new STCW, and what will happen to the SOLAS, what will happen to, there are lots of challenges when there are no safety, no seafarers on board. Are we talking on SOLAS? Whether SOLAS is going to be there. So these are all few things which are yet being debated. Whether a new convention itself will come for autonomous ships is also thing. The IMO recently in July, they had already concluded the scoping exercise, and I'm sure that a lot of things are going to change. So to conclude, I would just like to mention that the era of autonomous ships have arrived, and a different approach for operation and maintenance of ships will be required, and also the training for seafarers. There will be extensive use of latest concepts and technologies like augmented reality, virtual reality, HoloLens for remote operations, as well as troubleshooting and maintenance. The methods of training and certification of shipboard, as well as the shore-based personnel, also have to be changed. New and relevant courses will have to be introduced by various administrations, various countries. They'll have to bring in new courses. It could be a bridging course for the existing seafarers. I've just done a survey recently. For the last 2 months, I've been doing the survey, wherein right from the cadets to the seniors, at least about 600 reviews I've got across. And yes, the existing seafarers also are do confess that they are not ready for this type of training. In fact, they are not ready with the knowledge what they have. I don't think they'll be able to run autonomous ships. So they will also need to get a bridging course on these technologies so that they are into the industry. For sure, somebody says that, okay, an IT would probably snatch the job away of an engineer or a deck officer. I would say no, it cannot be done. learning engineering takes years together, strength of materials, fluid mechanics, whatever topic, thermodynamics, all this, it has taken years for an engineer or an nautical officer to learn. I don't think an IT person could learn this overnight. But a seafarer can learn sitting at home. He could learn these techniques. He could certainly get into AI, VR courses, 3 months, 6 months courses, and probably he would be ready. I think with that, I would like to thank the organizers once again for giving me an opportunity. Thanks for your patient listening. And I'm open to the questions. Thank you, gentlemen. And the ladies, thank you very much. All the ladies and gentlemen.
Thank you very much, Mr. Vakil. That was a very, very interesting presentation. And I will open the floor to any questions that we might have.
Okay, thank you very much, Mr. Sanjeev, for this very interesting presentation. You spoke about that there is a need for the change of the working culture on board. I think also the revolution in ships industry rate is not going together with the rate of legislation requirements. I mean the intermarine international conventions like SOLAS, STCW, they are not going together in parallel with this rate of revolution. And I think, I don't know that you are thinking about there is a need also for changing in the amendments of SOLAS, STCW. Maybe the Manila Amendments 2010 treats some of these, but not everything. And there is more needs for amendments in STCW, in SOLAS, especially the minimum safe manning. Thank you very much.
Yeah, I fully agree. So I fully agree what you said. You are right that few of these conventions, there will be a lot of amendments made because ROR, when you talk of rules of road, people say that now how are you going to investigate an accident where you will have a conventional ship and an autonomous ship? If they collide, whom are you going to catch? The master or the robo or the person who is ashore? So there are many questions which are unanswered as on date, but then I've been told recently that there is some working going across where a 2-lane system is going to come in, probably one for the conventional ships to fly on and one more the autonomous ships. So a lot of regulations would certainly change across, as you rightly said. Till now, STCW has been the slowest. It has taken 15 years, 20 years for from 78 to 95, 95 to 2010, and now 202X. Unlike whatever SOLAS, etc., every year you have a change. But I'm sure that STCW will have to move fast, and you'll have a lot of changes, a lot of training, and a lot of amendments are going to happen in due course. Thank you, sir.
Do we have any other questions from the floor? I have one from my co-chair.
Thank you. Thank you for your interesting presentation. I have a question concerning the remote troubleshooting technique. It is used for ships sailing with highly reduced shipboard staff. What about the fully autonomous ships without crew on board?
Yes, sir. If I could understand your question, you are mentioning that on a full autonomous ship without any crew on board. What's the question, sir? If you can kindly repeat. Sorry.
I am speaking about the remote troubleshooting technique. It is
okay.
Ships. You understand?
Okay. Yeah, a good question. Again, what would happen in a complete autonomous ship when there's no crew board, and then how would you have this remote controlled thing? Yes, it's a good question. But I would only presume that what could happen is when you have a technology, okay, the system with alarms, with you will have so many factors of safety, basically till that situation comes in. But the worst scenario would be to probably carry on a drone, probably you will be carrying across the equipment, and whether a human being also would be carried across, I'm not sure. But then that's the only way. If the technology goes to a level where the people on board, where there are no people on board and they cannot rectify a problem at remote, then I'm sure that they will need to fly somebody, and then that's how it can be rectified. So that is something which is going to be expensive for sure. Yeah. I think, yeah. So I would certainly like to see your comment on this.
Thank you for your answer.
Thank you, sir.
We have more questions from the floor.
Thank you. I was just wondering how you see this being implemented at our training institutions and universities around the world. Because my experience with new technology is sometimes our senior faculty either do not have the background in these areas, or they don't have a desire to change the way they're teaching or teach new technologies. So I see a transition period that, like you talked about, from sail to the industrial revolution of steamships. You could see a transition period, and some of our senior faculty may be reluctant to move towards autonomous ships.
Yes, sir. This transition would happen, and there will be certainly like a parallel voyage. What is done across, we will certainly have this transition because even an STCW transition, even the existing convention is 5 years. If it was 2012, 2010 came in, and then till 2017, I think it was not implemented. So this transition would be there, and I'm sure that it's not going to be so difficult. It's not going to be as challenging. I think the mindset is one thing which has to be. The technology will move at the same pace as it's doing, but mindset of the seafarers and people ashore. I've been told that, okay, I've been one of the largest shipping companies. When I interacted with them, they also mentioned that we would like to have crew on board. We will not like to have the technology driven ship because there are challenges. Today, if I don't find a chief engineer master who is not okay, next port of call, I probably sign him off. But what happens if it's autonomous and the technology changes? Probably we'll have to go back to them. So there are lots of questions, as you rightly said. The transition is going to be there, but then a simple example which I gave you across mobile phones 20 years back, we were not seeing it, and today we are with mobile phones. So let's not wait for a day when whether it will come or not. It is going to come, and we have seen examples where they have already come into the market. It's only a question of how expensive it is, how commercially viable it is what is going to be decided, whether it's commercially going to be viable for running such ships. Basis on that, I think the technology will drive it. Thank you.
Do we have any other questions? I think I would just echo that comment as well. There was one phrase in your talk that maritime education and training follows like a shadow to the introduction of technology aboard ships. And I would just encourage us all not maybe to follow that technology, but in the spirit of the title of this panel, to be innovators and to lead and to be partners with those technological advances. So